All right, looking at 4.4, this one's going to be a little long one. We have some definitions here, some vocabulary. Okay, there's something called a slope. And how you find a slope is rise over run. So you would go up on your graph and over. Okay. It's also could be your drop or roll, or your vertical change or horizontal change. So it's pretty much your rate of change, which is what this says. Your rate of change is your slope, just with a label. So more context there. Then you have something called a y-intercept, okay? This is where a line crosses the y-axis, okay? So your y-intercept is where your y crosses your y-axis. Another way to say it is it's the initial point or the beginning point, okay? It's where we go from there, okay? Then there's the x-axis, okay? That's really the x-intercept pretty much. So the x-axis is the same thing as calling it the x-intercept. And that's what you're going to see more often is your x-intercept. And that's where your line crosses the x-axis. Okay, so that's where our line crosses the x-axis. And for most of the time, it's the length of time. So your x-axis for almost everything is your amount of time. Okay, that's the key word there, time. So let's put this to practice then. Let's put this to some practice then. Okay, so in this first example here, we have the sentence, you deposit $500 in a savings account. You withdraw $50 each month, and in 10 months, you'll have $0. Okay, so our y-intercept is 500 because that's our starting point. That's where we started in the problem. So our y-intercept is our 500 because that's where we started from. That's the amount of money we had in the beginning. Our slope is what's happening each month. Each month we withdraw, so we lose $50 for 1 month. Okay, so that's why our slope's negative 50. Our rate of change just kind of reiterates that. Our rate of change is that just written in context. So that's why it's $50 in 1 month, okay? So that's really the same as the slope here. And then our x-intercept is our time. How long did this take? This took 10 months, okay? From here, what we're going to eventually do is be able to create an equation from this, but we're just trying to pick out the important information here first. So let's look at this first one. So we fill up a gas tank, and we could drive 300 miles. We can drive 25 miles per day, and we won't need to fill up our tank again until 12 days later. So let's identify some key information here. My y-intercept, remember that's our start value, our start. So how many gallons did we start with? We started with 300, and we're always also going to write it as an ordered pair. So 0, 300. Then our slope is what's happening. Are we losing miles? Are we getting miles? What's happening? Or let me re-ask that. How much gas is in the tank? Is it going down or is it going up? Our gas tank is going down. It's going negative. It's going negative 25 for every 1 day. Okay? That's why it says 25 miles per day. Now, our rate of change is when we put it into context. So we're losing 25 miles in one day. 25 miles in one day. Okay, so that's what's happening. And then our x-intercept is our time. Okay, so how long? It was 12 days or 12, 0. Okay. So now, why is any of this relevant? Why are we doing this? So let's go to the next page. This is relevant because now we're going to plug it into this equation. And this equation is called slope-intercept form. This equation is called slope-intercept form. ERCEPT, slope-intercept form, because in the equation, it has our slope and our y-intercept. Okay. And this information helps us build an equation. Looking at these bottom two, we're not going to do these because they aren't really relevant. So don't worry about those. Go to the next page. So on these pages, this is when we're going to start talking about the important stuff, such as slope and what it means. So we already know that slope could also mean the rate of change. Okay. Now there's a formula here that helps us when we're given 2 points. Okay, 2 ordered pairs. And again, we said slope is your vertical change and your horizontal change, or rise over run, which is what we're going to do, or drop versus roll. Okay? So now let's really talk about finding the slope of each line. So these ones are going to be where rise over run is important. So we're doing the rise over the run. Okay, so I want to figure out how many times does this first graph rise. So we're going from point to point. It goes up 1, so it rose 1, and now it's going to the right 2. Since it's going to the right, it's going to a positive 2. This is a positive 2. Okay, so it went up 1 to the right 2. Okay, so it went in the positive 2. So that means my slope, or my m value, is 1/2. Looking at the next one, we're dealing with these 2 points. So again, we do rise over run. So how many times does this go up? 1, 2, 3, 4, 5. It goes up 5. So my rise is 5. And now it's going to the left, 1, 2, 3, 4. So it's going to -4. So it's going to -4. So now my slope is a -5/4. Because again, it went to the -4 point on my graph. Okay, so when it goes up and to the right, it's a negative. When it goes up and to the left, it's a positive. Okay, so maybe let's write that down. Up and left, positive. Up and right is negative. All right, I want you to try this last one for me. So take a moment, try the last one, and unpause. So hopefully you got 4 over -2, but I want to remind you that you could simplify this. What is 4 divided by 2? It's -2 over 1. So we want to simplify our slope as much as possible. All right, let's go to the next page. Okay, so now we need to, in example 2, it says plot the given points and find the slope. Okay, so I'm going to start by plotting this point and then this one. So let's start with this first one. So I got a -2, +2. So there's my first point. My second point is 2, 5, which is there. Okay, so now I need to figure out my rise over run. My rise is up 1, 2, 3. So my slope is 3. And I'm going to the left, so it's a positive 1, 2, 3, 4. So, sorry, my slope is a positive 3/4. Let's do the next one. Okay, so I'm going to graph these points. -2, -5, -2, 2. So I'm going up 1, 2, 3, 4, 5, 6, 7. I'm rising 7, but am I running anywhere? Am I going left or right? No, I'm running 0. So whenever I have a 0 in the denominator, then my slope is really undefined. So my slope is really undefined then. Okay, so again, that comes from having 0 in my denominator. I want you to try number 3. Try that third one. All right, so hopefully you got a rise of 0 because it's not going up or down, but it is going to the left 5. Okay, so you may be thinking, doesn't that make it undefined? No, again, undefined is only when your 0 is in the denominator. Our 0 is in the numerator, so that makes it just 0. So our slope's, in this case, just 0. All right, let's look at one more. I know this says it's your homework, but I want to do one example. So you're going to use the formula given on the front, which is that your slope, or your m, is equal to y2 minus y1 over x2 minus x1. So the first thing I'm going to do is label which one's my y1, which one's my x1, and so on and so forth. So I always start with whichever ordered pair comes first. So this is my x1, this is my y1, this is my x2, y2. So now that I've identified these, I put them right into the formula that again is m equals y2 minus y1 over x2 minus x1. All right, so now I'm going to place my y2 in there, so it's 4, minus my y1, which was 2, all over, and remember this is m equals, all over my -3 minus 1. And now I can simplify that. What is 4 minus 2? It's 2. What is -3 minus 1? Hopefully you said -4. And can I simplify 2 and 4? Hopefully you said yes. I can make it -1/2. So then this is my slope, a -1/2. Okay, so you just plug it into this formula. And remember that this m value means your slope. So that's why we can use this formula. All right, try those other two for homework tonight.